Understanding the global importance of fresh water and its limited supply in today's world, where climate change is a real phenomenon, non-revenue water management is the first step the authority is taking to optimize the water being produced by the North Oropouche Water Treatment Plant as it attempts to meet the existing and growing demand for its customers. To this end, the first smart water network in Trinidad and Tobago is being established on the North Oropouche Water Supply Zone by a team of dedicated persons from the Water and Sewage Authority. The team aims to automate and digitize the production and distribution of this system.
North Oropouche, which is our second largest water production facility, though producing that volume of water, the water was not actually reaching the areas on its extremities. So for example, Five Rivers, coal mines, Coreal, Manzanilla. So in our attempt to better serve the population, we put together a small team of engineers and other special purpose practitioners to develop and assess the network towards producing a better supply to the community.
The North Oropouche plant was built and commissioned in the early 1980s, and at present the current capacity at the plant is 20 million gallons per day. There are limitations on the production at the facility which varies in extreme dry conditions as well as when there's extreme rainy weather conditions.
The potable water being produced by the North Oropouche Water Treatment Facility would exit the facility or be discharged by the facility via a 42-inch pipeline. This pipeline has approximately 13 or 14 offtakes, and there's no actual management of this water through the offtake. So basically we have a first come first serve. The offtakes closest to the plant would receive the highest pressures, the highest volumes, despite their actual need. We noted that proper management of the potable water along the distribution network had to be implemented.
After this upgrade, the plant will be continuing to produce 20 million gallons, but instead using 4 water pumps. We will now have that extra space, one pump, to become a standby so that in the event we have failure, we can easily switch over.
So what has been done differently with the North Oropouche Supply Zone is an end-to-end approach in terms of the automation. No longer are we just looking at automating individual facilities and boosters. We're also looking at automating the valves of the offtakes, which allow now pressure management to be done from the input at an offtake throughout the critical points located at the what one would call the worst case hydraulic nodes within the distribution system. Nodes that actually allow the authority to estimate how well customers are being serviced within that particular distribution or pressure management zone.
The assessment started with gathering data because we intended to solve the issues from a very data-driven standpoint. So we gathered data from an infrastructural standpoint, that is the civil, mechanical, electrical components as well as the automation component. So we would have assessed the efficiency of all of the pumps on the plant itself as well as the associated booster stations, the electrical as well as the mechanical. We also looked at the civil aspect of the raw water intake and the plant itself for their level of efficiency.
The concept of creating a smart water network is to improve the ultimate service to customers, improve their service and reliability.
And this will be done through the installation and implementation of not only flow meters as well as pressure loggers on each of the offtakes. We intend to also install smart PRVs which regulate both the pressure and the volume of water as needed through each of the offtakes.
Automation, therefore, is the foundation on which a smart water network is built. It's not the only component, but it is the foundational requirement to have a smart water network. So typically SCADA would look at facilities, but as we talk smart water network, and the operative word being network, it speaks to a wider penetration, the creation of a digital nervous system throughout our network. And mass distributional sensors will play an integral role in establishing this, and the first would have been the data logger. So the data logger basically is a simple device that measures either pressure or flow. It could do other parameters, but that typically is the 2 parameters that we use it to measure. And it will measure this in real time and transmit it telemetrically back to our central data store. The control system therefore has access to that information, and based on how it is programmed or algorithms that exist in terms of best practice for service deliveries, decisions can now be made on to what sort of pressures are required to give customers a better supply.
The gathering and capturing of telemetry data across the country is just half the process of actually utilizing the data. The other half would be displaying and visualizing of network across geographic planes. The multiple ways in which data is going to be presented will be done using the ArcGIS environment across the authority. Dashboards will be generated to allow managers and decision makers real-time information so that they can make more educated and informed decisions. With the data being captured, we'll be actually able to draw a real picture as to what is going on the plants. With this data, we'll be able to see where pressures drop off or flows increase, which will allow to alert managers in regards to issues that need to be addressed.
That data would allow better decisions to be made as to what is required to actually transition customers to a 24/7 supply.
With the establishment of our Operation Control Center, we'll have 24-hour monitoring taking place. With this real-time data, we'll actually be able to perform the duties of responding to customer issues regarding no water, low pressures, faster at a real-time pace. Visually understanding what is going on at our facilities, being able to quickly identify leaks, quickly identify anomalies on our system and address them on a 24-hour basis.
So together with the increase in the infrastructural work or the refurbishment of the various plants and facilities, we also intend to increase the level of automation both at the plant as well as along the distribution, transmission, trunk main.
We would move therefore from the source of our product, which would be the water treatment plants. We'll look at the transmission and distribution systems, and of course the facilities along the way such as boosters and wells, and we'll also look at valves and how we route water to customers. That allows us to do pressure management. And pressure management and the control and delivery of not just water, but the service factor, which has to do with the pressures that they deliver at and the schedules being met. That ability to optimize that delivery with those parameters is what comprises a smart water network.
With the capture of data, we will not only have data for one specific plant, but nationwide, both Trinidad and Tobago, allowing us to constantly monitor in real time all our plants and all our facilities. We'll be able to actually accomplish real-time job management of our employees. So, for example, reports in regards to leaks, in regards to no service, all these things will be actually populated on our dashboard immediately from our employees, so we know areas that we have to investigate.
Just the ability to be able to have pressure management being performed. The first benefit would be that the available water would now be directed to those who need it most. And we will no longer have the case of high pressures going to areas that don't need it and other areas along the system suffering from low pressures. Basically, with demand studies and pressure management, customers will get exactly the service that they are able to get based on the available supply. And definitely we should see more equitable sharing of the existing production capacity.
The Tucker Valley Supply Zone, also earmarked for automation, is unique in that the raw water supply and production capacity of the Tucker Valley Treatment Facility exceeds the collective demand of domestic and non-domestic customers. This means that with the implementation of non-revenue water management principles, continued operational good practices, and robust preventative maintenance, the entire zone has not only the potential to supply its customers with water 24 hours a day, 7 days a week, but it can also actually export some of this water to neighboring zones to supplement their existing supply. This outcome of supplying a 24/7 level of service will be achieved by aggressively repairing all leaks within the zone, implementing pressure management principles, optimizing the distribution of water within the zone, and increasing the ability to monitor and control the operations through full automation.
The leak management process, which is something that we'll be working on, is actually going to allow us to not only know where a leak is, but do things like spatial analysis to identify where we have weak points in mains, along a main line, or even in areas that need to actually be paid attention to.
SCADA itself is supervisory control and data acquisition. It really describes the components of hardware and software that work together to allow remote control and automation of facilities related to water treatment, production, distribution, and monitoring and control. Without SCADA, we wouldn't be able to manage facilities as distributed as we have presently.
The advantage of a GIS dashboard is that we'll no longer need the input of a customer to know when we have a problem. With the drop in pressures being shown and being alerted immediately, we would then know that more than likely there's a break on a line, so we can have these repairs done speedily and effectively so that the customer experiences the lowest latency possible in regards to getting a service re-established.
The added benefits in expanding SCADA throughout the country would be to be able to get efficiencies of scale, to be able to have staff work more smartly, to be able to know precisely where inputs to the organization go, how they're used, and how their resources could be maximized in terms of achieving customer satisfaction.
Once we improve the actual management of the water that is being distributed along the transmission main, each area or each community being served by this water treatment plant will in fact receive the needed pressures and volumes based on the demand. That is the population, the various types of industry, be it commerce, be it agricultural, etc. It will no longer be a first-come, first-served basis. It will be what you need as you need it. And that means we will have the water and the pressures at the extremities. So Five Rivers will no longer have a problem. Coal mine, North Manzanilla. We are here at WASA to improve our service to our customers. And we are doing this through the implementation, the establishment of a smart water network. WASA, a smart authority.
Trinidad and Tobago, get excited as we expand this digital transformation to your community. Soon, inconsistent water supply will be a thing of the past. Real-time monitoring of our system 24 hours a day will greatly improve our response time and service to you, our valued customers. WASA, being digitally transformed into a smart utility.